But what if we could? But what if we could? Many things in maths and science have been discovered because somebody had to ask, but what if we could? Let's have an arithmetic series with first term A and common difference D, and let's have a geometric series with first term B and common ratio R. The only reason why I've used B for the first term of a geometric progression was so that I don't use the alphabet A again, which over here denotes the first term of an arithmetic progression. Let's simply multiply both series term-wise. What do I mean? For simplicity, let's assume all the b's, the first term of the geometric progression, are 1. How do we get a general formula for the sum of this series? We're going to do something very similar to what we've done for the geometric series, where we multiply by common ratio to just shift the entire series to the right by one step. Looking at these two, let's subtract them. Minus subtracting vertically. On the left hand side, we're going to get 1 minus r and all of this gives us over here we have some sort of a hybrid between the arithmetic series and the geometric series by multiplying the arithmetic series and the geometric series term-wise. This series we just derived is what we call the Arithmetico-Geometric Series. Sum to n terms of the series 1 plus 3x plus 5x squared plus 7x cubed and so on. Notice that the coefficient side of things form an arithmetic progression and the x side of things form some sort of a geometric progression. Let's multiply this entire series by x. Subtracting vertically. Rearranging. You would think that given the formula up there, we're gonna be able to shove the relevant parameters of this arithmetical-geometric series into this formula and pop out the answer. You probably could, but it may not necessarily be any easier. Let's try. The initial term of the arithmetic side of things is 1, where the common difference is 2. The initial part of the geometric series side of things is 1, with the common ratio of x. And there you have it. It is not inconceivable to think that because this series has a common ratio raised to the power of n, that this series may have an infinite series based on certain intervals of the common ratio. Let the number of terms tend to infinity. The sum of an infinite number of terms exists if the common ratio lies within this same interval of -1 to 1. If the magnitude of x is less than 1, prove that the sum of this infinite series 1 plus 5x plus 9x squared plus and so on, all the way to 4n plus 1 x to the power n plus and so on, equals to 1 upon 3x over 1 minus x all squared. Firstly, noticing the denominator on the right hand side is some sort of a perfect square. We're going to multiply this infinite series by 1 and then by minus 2x and then by x squared and do our vertical subtraction. Subtracting vertically, the left hand side will be adding vertically, I should say. There you have it.